today I'll make a quick revision of what we have done in the motion. We are going to take a three-dimensional motion first, generalized it, where the displacement, this R I am writing as I cap x plus j cap y plus k cap z, and not like what I have done before, that x I cap plus y j cap plus z k cap. So why I distinguish like that? Because we are learning, we are beginners. So I would like to re-emphasize that the I, j and k, these unit vectors which we have taken in the respective x, y and z directions, these are constants. Because a differentiation exercise will follow, so therefore these constants which are invariants I have taken before. Later on, of course, you can write. In the first instance you must write like I am introducing to you, but later you can write this I from here to here, and here j here and k here, and it doesn't matter. But as kids, we must follow certain things, and I told you that if this displacement r is written like this, then the magnitude of this displacement r is equal to under root x square plus y square plus z square. Also, by definition, velocity is equal to rate of change of displacement. So I differentiate that with respect to time, and then I write quickly that I cap dx dt plus j cap dy dt plus k cap dz dt, which I can write because these components, this is the velocity component in the x direction, this is the velocity component in the y direction, this is the velocity component in the z direction. And remember, allow me to say that these directions are independent of each other. They are orthogonal. Okay, so I write this as I cap Vx plus j cap Vy plus k cap Vz, and obtain the value of the velocity here as under root of Vx square plus Vy square plus Vz square. And then I introduce the concept of acceleration. This is like this velocity was instantaneous velocity. The displacement was instantaneous displacement. This is also a variable. Like here I have taken x as a variable, y as a variable and z as a variable. The components can change, take minus, plus or zero values, whatever. So then I describe the acceleration here as ddt of v, rate of change of velocity, and then quickly go to write it as, from this expression I can write it as I cap, which is a constant, invariant, does not change, and dvx dt, dvy dt, j here, and k cap dvz over dt, which we can define, we can substitute the value of Vx as drx dt, Vy as dry dt, and dz as drz over dt, and naturally now we get a second order derivative, d2rx over dt2, d2ry over dt2, and d2rz over dt2. So I can write this expression like this. And since these are This is the x component, this is the y component, this is the z component. So I can write this expression as I cap ax plus j cap ay plus k cap az, so that I have my acceleration given as the magnitude of the acceleration a is given as x squared plus ay squared plus az squared under root. So I have these three expressions. One here for the magnitude of the displacement, for the magnitude of the velocity, and here the magnitude of the acceleration. Now these are the generalized equations which will be applicable to any situation in three-dimensional system. And if we want to describe the two-dimensional system, say by choosing my z to be equal to 0 here, so I can write my r as equal to I cap x plus j cap y, and so that r becomes equal to x square plus y square under root, where x and y are the x and y components of r. And similarly, here I can write it like this, wherein I will obtain the second equation for the velocity, the magnitude of the velocity v as equal to vx square plus vy square, and then in a similar manner I leave many things for you to do, because you can scribble, you have more means to help yourself in learning the things. You can go like a child, you can go like a beginner. It's always good to be a beginner. So r is equal to this, v is equal to this, and a is equal to this, in case the z is taken as equal to 0. Suppose if we take the y equal to 0 here, x and z, then I can write for y, I can write just z. So I have this z square, I have vz over here, vy will be missing, and I'll get this square is equal to like this, and this vz square here, r I can just ignore. And if it is, I take x is equal to 0, then I have y here, okay, with the j component, and z here with the k component, okay. So like that, you can again scribble the motion. For example, here it is in the xy plane. Then in the next case I can have the motion in the yz plane, and the third case I can have the motion in the zx plane. So these are certain things I wanted to remind you. And now I take an example of a two-dimensional motion, which we call a projectile, and try to put in the things which we have learnt. I told you about some nuances, some things about the cosine and sine functions that we'll use in the case of the projectile motion. As you know, and you can see that my projectile motion, in the projectile motion we have we set a body in motion, and it is the x z plane, but we'll take it as y, and suppose this we take as the vertical axis, and this I take as the horizontal axis. That is x on this side, and which also varies, y on this side, and we project a particle from the intersection of these two. Throw a stone, throw anything, but you know that there is an acceleration in the y direction. We'll take the acceleration in the x direction to be equal to 0. There is no acceleration that we'll have in the case of the projectile motion. When we throw a pebble, then what we find a trajectory which will look something like this. Something like this. Where my trajectory, the particle under consideration, which is taken as a point object. A point object is a very, very important concept in physics. All the mass of the body, even if the body has got dimensions, we take the motion of the center of mass of the body. And we project this body, then you can see in this trajectory, like before, here the slope of the trajectory is more, and as we come here, then the slope becomes less. Ultimately it reaches a certain height, and after which, so this is the ascending motion. This is the ascending motion in the field of gravitation. The field of gravitation. And this field is constant. What I have used the term the field of gravitation. And if we recall, I can say this G was introduced to you by me as equal to in magnitude equal to capital G, which is the universal gravitational constant, the mass of the earth divided by the square of the radius of the earth. And I told you that this is approximately, it is for example in my city and in most of the cities that you have, this is taken as 9.8 meter per second square, or approximately, which I can approximate as equal to 10 meter per second square. So why? Because in estimation problems, and particularly for kids like you who are going to answer the objective kind of questions where you have to make calculations, it is easy to calculate when 10 is there. Even another value I'd like to introduce to you right now, which is not relevant here, it is irrelevant, but still I would like to tell you as to what is the value of pi square. The value of the pi square again I will take as approximately equal to 10. You can make the calculation and you can find that the value is very close to 10. Nothing, no unit over here. You can't say radian square, or you can't say any other thing. So pi is approximately equal to 10. The other thing about G is that it is always pointed towards the center of the earth, and therefore in this picture which we have taken here, for the projectile to be moving like this, the value of G, the direction of this G vector is always taken like this. Okay, of course. Now I have made the projection. I have told you that this is the trajectory. On the trajectory, the slope becomes smaller and smaller and smaller, then it flattens out over here, and the descending motion appears to be like this. From an inspection of this, if we cut this like this, suppose I cut this curve like this. So observation is very important, and that means that this part of the curve is akin to this part of the curve, and of course the so this divides this range. So range is range R, range of the projectile, capital R. It consists of two parts. One is R by 2 when it is ascending, and the other is again R by 2. And because of the symmetry of the situation, because of the beauty of the situation, because of the problem that we have is beautiful, and therefore this becomes equal to R by 2 and R by 2. Another definition which we give is the maximum height of the projectile, or we can say, because this is y direction, so I can say y max. Okay, it's the same, the height of the projectile. And therefore you see that it is also found, and if you have read it or you will read it, then it is said that normally when an athlete throws a projectile like a shot put or any other thing, or even if you are, when you are going for a cricket ball throw or you have made a shot, then what you find is that the height is important, in the sense that if the projection is 45 degrees, we'll come to that, the maximum height is obtained, etc., etc. We'll learn the due course of time. So now I have the projection made with an initial velocity, of say u meters per second. Initial velocity of u meters per second, which if I project on the x-axis, I have a projection along the y-axis, then I have two components of this, and I can make this as the two components in the beginning at time t is equal to 0, when the initial velocity is u meters per second. There are two parts, and these parts I can say, if the angle of projection is taken as theta, then I can write this as u cos of theta in the beginning, and this is taken as u. So you can see that this velocity, if I take it like this, the velocity u was taken like this. This angle over here was theta with the x-axis, angle theta, and with the y-axis this will make an angle of 90 degrees minus theta. So this angle here is 90 minus theta, 90 degrees minus theta. Okay. And I told you that this projection here, this is u cos of theta. Horizontal velocity which we call, and this projection over here, this is u sine of theta. But in fact I told you that this is u sine of theta is obtained as, because in the resolved part that we make for any vector, we always go for the value of the vector multiplied by cosine of the angle between the two lines, and this will turn out to be, I'll just remind to you that this is actually the vertical component. Vertical component is u cos of 90 degrees minus theta. Okay. I'll not say to you that you straight away say that cos of 90 degrees minus theta is equal to sine of theta. But instead, I will ask you, and I will do so that you do understand how it is obtained by using the formula which I wrote as cos of A plus B. If there are two angles, A and B, then cosine of A and B, this turned out to be equal to cos A cos B, and here minus sine A sine B. It's very interesting, and that is why I introduced this thing. So cos of 90 minus theta, cos of 90 minus theta, 90 degrees plus minus theta, another angle. We have got these two angles together. So I will write now cos of A. What's cos of A? Cos of 90 degrees, cos of B, cos of minus theta, minus sine of A, which is 90 degrees, into sine of minus theta. Okay. Now, all we definitely need to know about the cosine values and the sine values, and there will be occasion when I will tell you all the values of sine and cosine. So I have cos of 90 degrees is equal to 0 plus or minus, and sine of 90 degrees is equal to 1. Cos of minus theta is equal to cos of theta, as I explained out to you, and you can go back to the lecture if you like. Sine of minus theta is equal to minus sine theta. So these are the things which we can scribble as a student on a piece of additional paper, and then substitute these things, and we will obtain cos of 90 degrees is equal to 0. So multiplied by something minus 1 into minus sine of theta, minus sine of theta. So the first factor here becomes equal to 0, the second factor becomes equal to minus into minus is plus. So ultimately this becomes equal to sine of theta. So this is how this value is obtained, you must know, and therefore I am just writing here u sine of theta on this side. Now, after some time, at a time t, suppose the value here becomes equal to v. The value here becomes equal to v. So you can see this remains unaltered, unchanged, and this value is v over here. V as a function of time t, you can see that the magnitude of v has reduced as the particle is ascending over here. Now, in the motion of projectile, the velocity component in the x direction or the horizontal component does not change, does not alter, because there is no force, because there is no acceleration in that direction. the acceleration in the x direction or the horizontal acceleration is equal to 0, and therefore the velocity, corresponding velocity or the speed, this remains unchanged. Here also, as also here, where the u cos of theta, the particle is still moving from here, but its vertical component has become equal to 0. So during its entire trajectory, everywhere, maybe here I show that u cos of theta will remain the same length, and even at the time of fall, there will be a u cos of theta. Okay, so this here, the cosine theta component, the cosine theta of component, from the beginning to the end, the moment it is executed, okay, and u sine theta, we will learn in the due course of time that u sine theta is directed like this. When the fall is there, then the velocity, vertical velocity of fall, whatever it was here in the upward direction, now at the time of fall, it will be in the downward direction. So these are some of the features that we have, and for the projectile motion, I will not go further. I will obtain and write the equations, etc., as to what is the value of Vt, how Vt varies, how the x component doesn't. It doesn't vary. The u cos of theta remains the same, and how the things are obtained. How is the rise where the vertical velocity becomes equal to 0? I have not written any equation, but the equations that we use, I'll just tell you, are of the same kind. V is equal to u plus at. I said the applications will follow. S is equal to ut plus half at square, and v square is equal to u square plus 2as. You know s is equal to delta x. So this, with the help of this set of equations, both for the vertical component and for the horizontal component, we will be able to obtain the maximum height which is reached, the range that we obtain, and the total time of flight. So these are some of the things, the equations that we obtain. They are interesting, they have interrelationship, and next time we meet, I leave it here. Why do I leave it here? Because I give you a chance to study all by yourself, come back prepared, and this is because I will tell you in the intermediate classes, in my intermediate classes, my mother, she insisted that she was not a very learned lady, not much learned at all. She could just write the small Urdu, etc. But she used to insist to me that when I go to the school where I had 5 subjects, English, Hindi, maths, physics and chemistry. So there used to be a timetable, and she used to get me up at 4 o'clock in the morning, give me half a boiled egg and half a cup of this thing plus some more things, snacks, etc. We could afford that. Okay, not many people could afford, So she will say, whatever is going to be taught to you in the class, you study. And when I used to go back to my class, I was one of the students who would ask anything I don't understand. I'll just raise my hand and ask my teachers, a chemistry teacher Pradhan Sahab, Saxena Sahab, physics teacher, and Theta Sahab, I don't remember his name. And I asked one of my friends from those days, he says, I also never knew because he was always Mr. Theta. He was such a nice teacher, and all the set of teachers that were there, not very often anybody will get offended with my questions, and they will go back, explain, because I had not understood that very concept. So I invite you to come back, and I will try to tell you more about this kind of motion where actually I am applying whatever I have done, and I can also show you how the various equations that we have obtained for the displacement r, for the velocity v, and for the acceleration a in the analysis that we have done, where I have used vectors I, j and k, etc., like which I revised for you again. So see you, I'll make these applications and then discuss these results and obtain the beautiful kind of a relationship which exists between the various things like the time period, the range, and the maximum height which is obtained when and how we'll get and we'll enjoy. Inshallah. Thank you very much for now. Bye. See you tomorrow.